Welcome to Analyst Crossfire, an ISC 2012 wrap-up show featuring expert voices from the international supercomputing community giving their reactions to some of the top HPC trends as discussed at this year's conference. I'm Addison Snell with Intersect 360 Research, and I'm your moderator for Analyst Crossfire. Joining me on the panel today are two vendors and two users who volunteered to share their opinions on any supercomputing topic I care to throw their way, giving us their personal views and not necessarily those of their organizations. Representing the vendor community, first we have David Turek, who's the Vice President of Exascale at IBM. Hello, David. You can say hi, David. It's okay. Next we have Elena Churakova, who's the Deputy CEO for Strategic Projects at T Platforms. Elena, thanks for joining us.
Hi, Addison.
From the supercomputing user community, we have two highly esteemed representatives of prestigious HPC sites. First, Donna Crawford from Lawrence Livermore National Labs and home of the new #1 Sequoia system. Hi, Donna. And finally, from the Center for High Performance Computing in South Africa, Happy Sithole. Good afternoon, Happy.
Hi.
Panelists, thank you all for joining me for ISC Analyst Crossfire. You know the rules. The clock is running. Let's get started. Our first topic today looks at big data. Big data, whatever it means, was one of the major themes of ISC'12. What I'd like you to do is pretend you're the analyst and you come up with a concise definition of big data, including, if you will, it's how it pertains to HPC. And I'd like to start with Donna.
Thank you. So what I want to say was last year at ISC'11 in Seattle in November, they ran a ticker to collect the data produced around the world. And they collected 10 exabytes in 1 week. So if you look at that for 50 weeks, that's about 500 exabytes. And that squares with a San Diego report recently that says we're generating about a zettabyte of data a year. However, we only have about order 100 exabytes of disk tape in the world. So we're generating more data than we have room to store it, which none of us have to worry about the entire amount of data to deal with. So that leads me to my concise definition of what it is. It depends. Much like supercomputing, I think that's pretty concise, right? Much like supercomputing, it's sort of like, so if you have to have a new strategy to store it or analyze it, then you have big data. And you have to consider how long to store it and how long to throw it, when you throw it away.
Happy, Donna's primarily focusing on the volume of the data. How does your definition look?
I agree first with the volume. I think it's very important. But I would say the other dimension that we have to look here is that when you have got data, you should be able to make sense out of it. So analysis and how best we can be able to analyze it. But the other dimension is that data, for it to be able to be accessed by anybody, I think visualization becomes very important on it. And at the moment, some of the data that we have, we can do those things. In areas where we can't be able to do those things, that's my definition of big data.
Elena, the users are primarily coming from the point of view of these traditional supercomputing sites. What does big data mean to you?
Okay, we could say that big data is a problem faced by customers whose ability to produce and accumulate data is growing much faster than their actual capability of producing information and knowledge out of this data. This is a constant lack of technologies, hardware, software tools that they're facing, that they need to handle these data and produce something useful out of it. And this definitely leads to a situation where a normal path from data to information and to knowledge is actually blocked at some point. I cannot say that we face a lot of these applications in Russia so far. An example I could give is something close, but not exactly this. It's the largest Russian search and analytical engine, Yandex, which just face a constant need to update their hardware infrastructure, and they do it almost every day, but still they constantly lack technologies to handle the data and analyze the data that they're collecting. As our organization is concerned, I would say that the problem that we're more frequently faced with is the data-intensive HPC applications. And we do some software development to this end, which were the tools that can be actually used in the future to handle the big data problem as well. This is like developing a software framework designed to effectively handle complex and non-regular communication patterns, which is a cross point between big data and HPC intensive applications.
So the definition got a little broader and somewhat less concise when we left the user, went to the vendor. Dave, IBM, in your view with big data?
So first of all, we look at the fact that all the data that exists in the world today, 90% of it was created in the last 2 years. So the rate and pace with which data is being created is dramatic. We view big data as a combination of volume, as Donna spoke about, but also variety. Every kind of type of data is being factored into this definition and has to be construed as an elemental part of what the problem is. And then there's this notion of velocity, which really talks about the speed with which data is coming up for analysis in the context of looking at a progressive pursuit of real-time analytics or real-time insight into the data. So it's the 3 V's, volume, velocity, and variety, that constitute the framework for what big data is. This becomes critically important into the HPC industry because it has 2 material implications. One is it forces you to look at the workflow of the problems of the future. And what that means is you have to look at the entirety of the problem from an analytic perspective, because in the future, you'll spend substantially more time on the preparation and acquisition of data and the interpretation of the output of the analytical part of the problem than you will about analysis per se. So, for example, if you were to apply a bunch of accelerators to a narrow kernel and applaud the fact that you maybe have gotten a 50 or 100x improvement on the kernel, you have to put that in the context that that achievement might actually be irrelevant relative to the amount of time you have to take in the manipulation and management of the data associated with a problem. It's sort of an analog to Amdahl's law, but at the context of the workflow level. And so
I think when we get outside of some of these supercomputing definitions, we see these broad enterprise class definitions, and really we count 7 different categories of big data applications. So it's very difficult to pigeonhole into any one place. That's what makes these concise definitions so difficult. Our next topic is we're transitioning into an HPC future that's increasingly based on multi-core processors and heterogeneous architectures. So as we march toward exascale, how should programming models change to start to accommodate this? I'll go right back to Dave.
There'll be a tension between a desire to pursue different kinds of models to make things a little easier with the hybrid models of computing in the future. But it's going to come up against the tension of trying to move the install base forward. So we think that the existing programming models will be sustained quite far into the future. We think that the principal discourse will be between where the burden will be placed on the programmers. From our perspective, we'll do a lot with compilers to make that as straightforward as possible.
Programming models, compilers not really change and go forward to exascale. Donna?
Right.
Donna?
Well, what they should do versus what they will do may be 2 different things. We just heard a session for over an hour and a half on programming models, and there's a lot of complexity, a lot of variety, and a lot of really great research going on. They're going to have to provide our users with the power and the flexibility to define, where you're going to do the computation, the relationship between the computation and the data, when to expect the data results back, and but at the same time recognizing the uncertainty that because you're sending data off to these heterogeneous application, these processors, that you won't get it back when you think you're going to get it back. So you have to be able to take all that into account. So I think we're going to have our imperative languages will continue, but they'll coexist with a sort of a growing set of specialized languages.
Happy, are you seeing any changes in how you're programming systems?
Definitely. At the moment, if you look at how the systems are growing, and we, after the power of the processing, that's why we are at this stage having these heterogeneous systems. But we ignored how the users are going to be affected by this. And what the session that Donna is talking about, the screams that we hear from the users is that we want simplicity. We don't want to see what is right at the back, which is more complicated. Let it be simple. And I think that it will go there because computing is driven by the users.
A couple different views coming from the user side. Elena, how do you see this playing out?
Well, if we talk about sustainable exascale, it is obvious for us that it is impossible to reach if we don't reach tight coupling between hardware architecture design and software architecture design, which is obviously leading us to a thought that programming models should take into account different hierarchies of the system architecture, meaning interconnect hierarchy, memory hierarchy, and storage hierarchy. So these models, in our view, tightly coupled with the hardware design, will not only should evolve, but will evolve. But we cannot say at this point, of course, that legacy models like MPI and newer models like PGAS will die out. They will not. But it is probable that they will be used as low-level programming techniques within the software frameworks, which are designed to increase productivity and to reflect better system architecture. As we speak about languages, well, we would like, of course, to see, and we hope, and we definitely will see, languages more parallel in their nature, meaning that the programmer can more easily implement parallel data structures and parallel operations using them. And ideally, those languages should have capabilities of the models that we have just discussed. But although these languages will evolve, they probably will not substitute the old languages, and they will probably not be used as widely, because we use the same languages now for non-parallel programming as well as for parallel programming, and non-parallel programming is just a much larger bulk of code, and a lot of efforts is...
Dave, you've been really patient down there while some people disagreed with you. I want to get back to you while there's time on the clock.
Well, it's a matter of the economics of the marketplace. I mean, I think there is an ambition to try to change programming models, but there are trillions of dollars invested in the install base of software today, and moving that forward requires a pretty Herculean effort. So I think MPI, OpenMP will persist for quite some time. I think there'll be a lot of experiments, the PGAS languages, et cetera. But the acceptance in the marketplace of a programming model is pretty highly problematic. That is a new model. And I think that maybe the bigger chance for change to come will come out of some of the emerging economies where you have new approaches being experimented and there's not that install base to worry about.
Well, you know, when we start looking ahead at who's going to help us solve some of these issues, it transitions us right to the next topic, which is one I'm frankly concerned about. I'd like to ask all of you to look out at our audience for a second before you answer this question, and then come back around to what do we need to do to attract more youth into high-performance computing. Happy, what do you think?
First of all, when I look through the audience, I see a lot of youth here. And yeah, the reality is that if we have to make people to consider HPC as a career, is first, how is it visible out there? Is it like, does it represent a charming career? So that's the first thing. Application of it, do the youth see this as a possible career option? But then I would say so far some of the programs that I'm seeing, for an example, the Student Cluster Challenge, it really gives us an opportunity to groom a new generation of HPC practitioners. So those are some of the things that we need to put in. So
I was pleased to see the student cluster competition get added to ISC. Elena, what do you think?
Well, you know, if you look at our company, our average age is slightly above 30. So in Russia, it is an obvious situation. We're not having the problem of aging of HPC specialists.
This is your competition model, so you're just going to outlive them all. Is that the idea?
We're facing the lack of expertise, which means actually that we're actively...
Organize a swap.
Actually headhunting and finding just young people with big potential, and we have to grow them within the company.
Hire me, right?
Dave, average age at IBM is just over 30, right? In HPC?
So actually...
Geez, your company is 100 years old.
No, actually it is, because you see the essence of this question is very Western oriented. But if you look at, for example, what's going on in China, in our Chinese development lab and our research lab, it's under 30. If you look at what's happening in our India labs, it's under 30. So it all balances out. So when I throw myself in, it gets to be a little over 40. But I think that there's a lot of energy coming from the developing economies around the world that really are supplying the youth. And as Elena said, it's a matter of how you impart experience to that energy of youth that'll bring this forward. And that's why our HPC development activities are actually spread worldwide. We want to leverage that knowledge, we want to leverage that energy, and we want to teach these people what to do, and they'll carry it forward through the next generation.
Is that because they're the only ones willing to learn Fortran still? I mean, if we get more Americans in it, if it was in XML. Donna, how are we doing here with youth?
So I didn't think that there's a problem either. Maybe it's because you see some of the same old faces, mine, over and over again, but that's because you get in it and you get excited about it. But I hire 50 to 70 people a year, and I hire them, you know, most of them straight out of school. We have a great postdoc program. We have a great student program. So I'm not seeing this as a problem. But I do agree that we have to continue to make it attractive, that we're solving important societal problems that people are excited about solving, and that'll keep them coming.
I'm going to argue that it is more of a problem than this panel's reflecting here. And if we went over into some of the commercial markets, finding engineering talent who's good at HPC also is somewhat hard to do for some of these companies. I don't know if anyone wants to react to that. Elena, you're nodding at me.
About the customer base, you mean?
About the HPC user community, the commercial HPC user community, being able to find enough talent.
Guys, I live in Russia. You really believe that we have a large industry HPC community?
Happy.
Youth in HPC industry? I would say getting also the complexity of application of HPC in industries, you have to understand. Let's take here in mining industry. If I have to take a young person to go into mining industry, first have to understand the processes in mining, and after that, then you still have to understand HPC. So you have to know two different worlds. So we need a sort of a jump start here, I think, of the skill and also the particular industry where you are going to apply HPC. So it's not an easy task.
Go ahead, Elena.
Well, I would like just to add a tiny point to that. In Russia, we're facing with exactly the problem of growing HPC in the industrial community, and we have certain enabling programs for them, meaning that we do actually applications for them and simulations end-to-end, which means that they are able to actually participate in solving their tasks by means of HPC. And what we see is the interest of young people towards that is greater, and we are, you know, these efforts are actually basing on younger people in these organizations, in customers' organizations, because older people are so well rooted in their older methods, and So.
Well, one thing I think is going to be really important is that this can't be HPC just for the sake of HPC. But you know, what keeps me addicted to this industry is how cool the applications are. And if you link it to what can be done in engineering and science, I think it's maybe not so long a walk to show young people where some good careers are in all this. Those are our long answer questions. Let's really speed it up, go to the speed round here. Throughout the transition to multi-core, memory per core we've seen in our research has stayed relatively constant in HPC configurations. It's actually gone up a little bit, which has made memory per node right through the roof. It's currently a little over 64 gigabytes per node on average. Is this sustainable, or do we have to do something different, Elena?
Well, since the technology nodes used to manufacture CPUs and memories are evolving in parallel, we believe that for general purpose CPU-based nodes, the tendency will stay, so the memory will grow in parallel with the capacity of these CPUs. But
Dave, what do you think? Is that going to just keep growing?
No, I think it's going to have to be rethought. You know, we did the Apollo program with 64K of memory. And I think we've gotten sloppy over the course of time in terms of programming technique. The cost of memory will drive people to less memory per core than more over the course of time.
Happy?
Looking at the growth of the applications and the demand in memory, I think that from the user's perspective, there will still be a demand in the growth.
You want to just keep putting more memory into that node?
Yeah.
You don't care. Donna?
I think at the low end, I have to agree with Happy, but at the high end, as Dave says, it's unsustainable. We won't, at 100 petaflops, we won't be able to afford the kind of memory you think you might need for that kind of a machine, so something's got to give.
I interrupted you before, Elena. I'll give you 10 seconds back.
It's just about the many core and GPUs and heterogeneous architecture. The amount of memory used for these machines will definitely decrease if we count per core.
Be very careful with this next question here, because I got a marketing background, but we do marketing consulting with our clients sometimes, and yet the end users tend to be a pretty well-informed group. How important is good marketing for an HPC technology vendor, Dave? Let's build a smarter planet.
Yeah, right. I mean, it's critical if you conceptualize marketing as a conveyance of information that has use. And we all know that there are certain perspectives in the HPC industry which are less informative than they need to be. So it's very important to get people to focus on the right things to solve the right problems with the right technologies.
Elena, what do you think?
Well, I think the purpose of good marketing in HPC is precisely increasing the size of this well-informed group. This is it.
So marketing is important for going after the new users,
Absolutely.
but the existing users don't need it.
The existing users need networking.
They need. I like that as a concept. Donna, what do you think about Dave using marketing to tell you what's important?
Well, I'm going to figure out what I think is important, but I think if Dave doesn't show up or Elena doesn't show up at ISC in the exhibit floor or SC, I'm going to think there's something gone wrong, and I'm going to pull away. So I think it's very important to continue marketing.
There's a few companies I noticed weren't here this year, so I took note of that. What do you think, Happy?
Yeah, I think the marketing of HPC, maybe from my perspective, is the vendors should look at presenting solutions to problems, working together with the community on real-life solutions rather than showing the machines. I think that's important. And from us, the users, is to continuously grow other applications of HPC and solving real-life problems.
I love some of the points that got made around community building. There's a lot of different kinds of marketing, and relationships are so important in this industry. It's one of the great reasons I come to ISC. Last speed round question. I'm going to have a lot of fun with this one. We're going to play over-under on a couple of topics. You got to fast forward in your minds 3 years from right now. It's ISC'15. The top 500 list has come out. How many of the top 20 systems on the top 500 list are in Europe, Elena? Over or under 4?
About this amount, but if we count Russia in Europe, it's definitely be more.
It would be over 4. Donna?
Yeah. Oh, it'll be over, but of course you have to consider the European economy, so something could happen.
Why do you think this is getting asked? So you're going over despite the Eurozone crisis?
There's 7 in the system.
I know,
now.
I'm saying 3 years from now.
And there's wonderful investments, so unless something serious happens.
You said over. Happy?
I think it will go down because some of these systems are going to go to Australia and South Africa.
Under 4. Dave?
Under 4.
Under 4 from Europe. Next, how many systems total in the top 500 are based on ARM processors in 3 years? Over or under 12, Dave?
It'll be 0.
That's well under 12. Happy?
It will be over 12, looking at the issue of data and opportunities that ARM is presenting.
Over 12 from Happy. Donna?
It'll be 4.
4, well under 12. Elena, over or under 12?
We believe in this technology and we would like to see more, and we hope to see more.
Over or under 12?
Over.
Over 12. The number 1 system on the list, over or under 100 petaflops in 3 years, Elena?
Around 100 petaflops,
over
but not in...
Over or under?
Okay, over, but not in June, in November.
Okay, Donna?
Over. 6x where we are today is a piece of cake.
Happy?
Under.
Under 100 petaflops. Dave?
Trick system over, real system under.
All right, so you went over. All right, I'm not giving up on this topic. The slide advanced, we're hitting the last one anyway. The largest deployed HPC storage infrastructure in 3 years, over or under 10 exabytes, Donna?
Under. If I double my storage space, I won't even be at an exabyte. If I double every year between now and then, I'll not
Happy,
even be
over
exabyte.
or under 10 exabytes in 3 years?
Over.
Over. Dave?
Under.
Under 10 exabytes. Elena?
Under for traditional HPC, but over for big data.
I love this game. Thank you, panelists. We're going to wrap up traditional analyst crossfire with our traditional analyst crossfire final question. 1 up, 1 down. You've experienced the show so far. It's kind of you had to reflect on this over the course of the week. I want you to each tell me one thing you were really impressed with this week, and also one thing you were disappointed with. I'll start with Elena.
Well, we believe that the winner is definitely IBM nowadays, with their 20 Blue Gene Qs installations in top 500, and 4 of them being in the first 10. And about the loser, I would say it's our exascale path, if I may say so, just because we don't see a lot of disruptive technologies coming up. We're all waiting for them, but they don't come. We don't see any.
So IBM's winning all the way, but not enough to get us to exascale.
Well,
Donna?
this is not really a new technology. It emerged earlier than this ISC, okay?
That's fine.
You may consider this a punt, but I actually had some new people come to this conference from Livermore for the first time, and so I'm going to say the conference, the way it's organized, the pace, the size, it gives you a lot of really great information in really good format. So I'm going to give the conference. I would normally call that a punt, except that I happen to agree with you in this case. No, wait, you're not getting out of the down category, the disappointment. The down category, leaving Hamburg. Because that probably means we're getting bigger, Hans.
That is a punt. Go ahead, Happy.
Yeah, I think the conference is always well organized, and we every year see new things. So what really impressed me is some of introduction of the technology, and we talked about youth. I think Martin, he's putting a lot of other things that youth associate this conference with. So that's what I'm impressed with, including the student cluster challenge. I agree with you there, too. As much as I love Hans, Martin getting involved, there were a lot of updates to the conference this year that were very refreshing. Go to your disappointment. I share the same sentiments with Donna. Hamburg was home now. You know, I love Hamburg. I agree with you there, but you guys are also wimping out on that question a little bit. If there's any time left on the clock, I'm coming back to you, but Dave might use it all. Dave, you got the last word.
So I was really impressed with that company did the Blue Gene Q. But
Elena already used that one, so you might have to find something else.
No, I was actually impressed with the presence of both the Eastern European companies and the Chinese companies and other centers here, which makes it truly more international. From a disappointment perspective, I'd like to see the composition of attendees be more balanced between different countries in Europe. This is a very German-centric thing still. And I'd also like to say one other thing I was impressed about, and that was the presence of a fair number of EC officials here, European Commission officials and EU officials, that are paying attention to this, which I think is important.
Panelists, that concludes ISC Analyst Crossfire, and with it, the 2012 ISC Conference. I'd like to invite our audience to look for Analyst Crossfire again at the conclusion of the Supercomputing 2012 Conference from Salt Lake City this November, and next year from ISC 2013 in Leipzig, where I'll be joined by new panels of experts on current sets of forward-looking HPC topics. I'd like to again thank my panelists, Donna Crawford, Happy Satole, Dave Turek, Elena Cherkova, for joining me and sharing their insights, as well as Hans and Martin Moyer and the rest of the ISC events team for another successful ISC conference. For Analyst Crossfire, I'm Addison Snell, Intersect 360 Research. Thank you.
Addison, thank you a lot, you and your colleagues on stage. It was again a great event for me, and therefore I invite you already to come back at ISC 13 in Leipzig.
I hope I will. I just said in the video.
Yeah, you said it, but I also have to agree, of course. And now I like to introduce you to this man. If you are a soccer or a football expert, you must know him. It is Sepp Herberger. He was a man making Germany in '54 the world champion in soccer, and he is a very famous man. He was one, and is still after he has died, of course. And he had the famous saying, after the match is before the match. And I will vary a little bit. After ISC is before ISC. You have learned that we are going to Leipzig. And this is our new homepage. We just have started with a homepage, and you are invited to visit the homepage from time to time. There will be introductions to the conference. It will be filled by the sponsors of the conference, by the keynote speakers, etc., etc. Please visit our homepage in the next couple of weeks and months. And in the next days, beginning of next week, you, the conference attendees, will receive automatically an email how you can get all the slides of the speakers delivered to us and how to access it on our web server. So, thank you for attending ISC'12, and see you next year in Leipzig. Here is a date, June 16 to 20, and I am convinced that again we will have a good conference, and you will appreciate coming to Leipzig. Thank you for attending ISC'12, and here's the next thing. You are invited. It's our farewell lunch. And, you know, the normal days of the conference, alcohol is not allowed at lunch. But today, after the conference, it is allowed. You are invited to drink a cold German beer and have a safe and sound trip home.